Good morning. This is Jan Martin coming to you from her dining room again to have another science blast. And today we're going to be doing kitchen chemistry and looking at different kinds of reactions that we can create using everyday household items from the refrigerator, the cupboard, and wherever. So we're going to start by we're going to blow up balloons today is one of the things we're going to do using a couple of different techniques. And one of the techniques we're going to start with is using yeast. And so I'm taking a glass bottle. I used these bottles last week for sound. And I'm pouring some warm water into the bottle to the directions said to 3 centimeters, which means this was something I found on the internet that came from England, because I'm using centimeters instead of inches for measurement. So I've got the warm water in the jar, in the bottle. Now I'm going to pour some yeast in. And I know on this day where it's a little hard to find yeast, I actually have some. And if anybody would like to try this experiment at home, let me know and I can give you some yeast, because I ended up finding a 2-pound bottle of yeast. And so what we're doing is we're mixing the yeast with the warm water to get it working, because yeast is a living organism, and when we put it in water, it activates it. And yeast needs something to eat. And so we're adding to this bottle a teaspoon of sugar. And this would be the same basic procedure that you would do when you're getting ready to start making bread or any other yeast-based baked good like cinnamon rolls or something. So now, to capture the byproducts of the reactions of the yeast and the sugar, we're putting a balloon over the top. And we're just going to set this aside because the yeast takes a little time to activate. So now we have yeast, sugar, and water. And the yeast is going to be eating the sugar. And we're going to see what happens at the end of the session today. So something a little simpler that I started on Saturday is some sugar crystals. And so basically what we're making in this jar, you can kind of see there's things going on in here. I'm going to pull this up. So I've been making basically sugar candy or rock sugar. So I'm going to push it back down in, and we're going to talk about how you make it. So this is made simply with sugar and water. Normally when you mix sugar and water together, we're looking to dissolve the sugar, and so that it becomes a solution. Well, in making the rock candy, instead of making a solution that is sugar and water, equal parts, so 1 cup of sugar to 1 cup of water, which would give you something that looks like this. This is known as simple syrup, and you cook the sugar in the water until it gets all dissolved and you don't even know there's any sugar in there. Well, in making this, used a whole lot more sugar. You would do 4 cups of sugar to 1 cup of water. You mix it and you heat it and you heat it and you heat it and you heat it, and you need to use the heat to get the reaction going so that the sugar starts dissolving, and heat makes things move faster. So that's where you get it going, and you cook it until it gets to about 210 degrees. So we're almost turning the sugar and water into candy. We slow it, take it off the heat, and you're going to put it in a jar that's been prepared. So the first thing you have to do before you make the sugar solution is you need to prepare your rope that the sugar clings to. So this is just string tied to a straw with some big knots at the bottom, so it's a little heavier. And then I soak this, and you soak it in a sugar solution overnight, and then it dries, and now you have something for the sugar to cling on to. You put the sugar solution in the jar. You add some food coloring. You can add some edible glitter, which is where I used yellow food coloring and green glitter. So I have this interesting solution going in my jar, and you take it out and you can look and see the crystals, because the crystals look much bigger than they did when they were just plain pieces of sugar. You can do the same thing, making a saturated solution of salt, and make salt crystals, and it's kind of fun to do one of salt and one of sugar and look at the difference between the two. So sugar crystals, and then you can eat those. So that's really nice. So it's edible chemistry. And the thing to think about when we are thinking about kitchen chemistry is really pretty much everything we do in the kitchen is chemistry, because we are combining unlike ingredients a lot of times, or we're agitating, we're using heat, we're using a mixer to mix things, changing butter and flour into a mixture. So all of what we do really is involving science and chemistry. Well, now I have a really fun one for us. So, did you know you can make your own butter? Again, this is another little kitchen chemistry activity. And so Saturday, I made some butter. Now, it doesn't look pretty like the butter does when we get it in a stick in the jar. That's just because I chose to leave the butter in this jar and not form it up into a patty or something. And then, so I got the butter, and I got what was left, which is known as buttermilk. So we're going to talk about how do you make butter. Now, this is one, moms and dads, that if you've got some whipping cream, all you need is a jar with a good tight lid and a cup of whipping cream to get what I did here. So what you do, and this is a good one when people are saying, well, I'm bored, what do I want to do? Today it's rainy and icky out, so you could do this if you have some whipping cream in the cupboard, and you do in the refrigerator, but you do need whipping cream. So I'm going to put some whipping cream in the jar. And yes, if someone were to ask, so what do you always have in your refrigerator? Well, I have a couple of strange things I always have in my refrigerator, one of which is always whipping cream, because I use it for a lot of different things when I'm baking. I like to make pudding with it, so instead of all milk, I whip up some cream and make it more like a mousse. But that's Jan's cooking tips, not Jan's kitchen chemistry. So now I am just, all I did was put the whipping cream in the jar, put the lid on, and then you start whipping. And you, instead of using your mixer to make the whipping cream from scratch, you're going to shake the jar. And you're going to shake a lot. It takes about 20 minutes to get the changes where we're pulling out the fat out of the suspension the fat out of the milk, the liquids. So we're pulling the solids out of the liquid, and the whipping activity, the agitating, is what's going to do it. And already, just even with this little bit of action, we can start seeing there's a little bit of foam forming in the jar, and the whipping cream is coating the jar. So I'll do a little more whipping. And this is a good one on a day like today where, you know, you can't go outside and play and you need to release some energy. Pass the jar around, and everyone can take turns shaking the jar as hard as they can. And you'll notice over time, it will start sounding, you can tell when change is happening by listening to the sound of the liquid in the jar, the cream in the jar. So we're going to keep going and 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 going. And I'm going to stop because it's not very exciting to watch me just shake the jar. But you would, if you do this, you can notice what's happening. Okay, so we're going to revisit the yeast mixture, and we can start seeing some foam starting to occur and happening here on the jar in the glass bottle. So far, it's not enough to get the balloon to inflate, but it's definitely working. The yeast is live and letting off chemical combinations that makes the foam. So we're going to put this down, and we're going to go and do the most complicated of the experiments that I did set up for us over the weekend. And this one goes back, uses something I used back earlier, just before Easter, where we did, excuse me for walking away, but I need to get some things. When we used red cabbage juice to make Easter eggs. Well, red cabbage, you cut up the cabbage, you put it in some water, you let it cook for a while, and then you get the juice, and you should get a jar full of a reddish, purplish liquid. So now what we're going to do is make changes to the juice. We're going to look at reactions. We have acids and we have bases. Acids are things like vinegar. Bases are things like baking soda. So what we're going to do now is we're going to take, so I took the red cabbage juice and I added enough baking soda to it so it turned a blue color. And then I popped it into some ice cube trays, and now I have frozen red cabbage juice. And what was really funny is when I went to put this into my freezer, the cabbage juice leaked a little, and it leaked onto some of the other things in the freezer, so I have to clean the freezer to get the cabbage juice out. Now, something else very interesting happened to me when I was making the cabbage juice, and this is something that, boy, if I was teaching high school chemistry, would be a really good one to really study carefully. These ice cubes look a little different. They're not quite as blue. Well, this is what happened. My first batch of cabbage juice, I just cut up the cabbage juice and turned on the main kitchen faucet and covered it up and started cooking it. And I looked at it, and it was blue. I wasn't expecting a blue because I wanted a red. Well, my plumbing system has a water softener, as many of us do. And so I do believe what happened is the softened water created a very different reaction than did the filtered water. So then I had to make another batch using the filtered water. So here we have two different kinds of cubes. I have the ones made that were red that turned blue. And now these are the ones that just came out blue from making the, so we're going to see if anything different happens when we do this experiment. So first, I need to put some vinegar. In the jar, in the glasses. Oop, that's interesting. I've had this vinegar a while. Never had that happen before. Well, I guess it's time to get a new bottle of vinegar. Okay, now I need my straw. So what I'm going to do is put no, I don't want the baking soda, I want the straw. I'm going to put some, and you can use the straw like you would. And, well, I put a little vinegar on the cube and we are getting a color change. So I'm going to put this cube into the jar, the glass with vinegar. And we're going to watch the change. So what's happening to the jars, the glasses with the vinegar. First, we're getting a color change, and that's the baking soda reacting with the vinegar. Now, since this was the one without any baking soda, just the tap water that is from the water softener, we're getting some change, but not near as much. So we're going to put this one down. And the other thing I'm going to do is I'm going to put some more cubes in here. And we need to watch. So we're getting the vinegar reacting with the baking soda and the indicator, the red cabbage juice. And we're also getting some fizzies starting to build up on top. This is not the kind of carbonated soda I would want to be drinking. But what we do now have is a reaction between the vinegar, the red cabbage juice, and the baking soda. So we're turning the blue into red, as well as the reaction with the cabbage juice. And so we're getting everything reacting. So I'm just throwing the rest of those in because I don't need those anymore. And we're going to take another look at the balloon. We see the foam, and we've got lots of reaction going on in the bottom of the jar. There is obviously something being given off, some gases that are allowing the balloon to blow up. And with this broadcast, we have provided you the links for all the different activities that I've put together here. So I'm going to do a little, check this out again. And we're going to do one more balloon blowing activity. And so if you want to do any of these activities, they're fairly easy to do. The one I just did using the fizzies is the most involved. And unless you want to buy and cook the red cabbage, this is a good one to do in a classroom with kids too, so that it's a little more control, you have everyone together. So the final thing we're going to do, we're going to play a little again with some vinegar and water and baking soda. And this time I've got a half a cup of vinegar and a quarter of a cup of water in the bottom of a water bottle, plastic bottle. You could use a drink bottle, whatever, but it needs to be a plastic bottle. And in the balloon, I have 2 teaspoons of baking soda. So this time we're going to directly watch what happens when we mix baking soda and vinegar and see what it does to the balloon. So you very carefully put the balloon over the water bottle top, making sure you don't have any baking soda slipping down. So now we've got the baking soda hanging here. And in this case, now what we do is, and a very immediate reaction, much faster than any of the other reactions we've seen so far today. And that's the baking soda mixing with the vinegar and creating carbon dioxide, which is blowing up the balloon. And this will go for a while. And actually, when I did my prototype, the balloon stayed inflated for quite some time. Now, something you could just you could try to experiment with is see what happens when you take this off. Of course, you can never tie a balloon quickly when you want it to do this in front of people. Well, somebody who's better at tying balloons than me could do this part. And it behaves very much like the balloon would behave when you were doing this. Now let's see if there's anything left in terms of reaction now that I've taken it off. Nope, we pretty much totally consumed the reaction in the jar. So today we did some kitchen chemistry. We've got this balloon inflating. It takes a little longer for this to go, but even over the 20 minutes we've been doing this, we can see quite a bit of change watching the yeast do its activity. And this is a nice segue into talking about next week. And next week we're going to be doing sourdough. Sourdough, again, kitchen chemistry, but sourdough bread, sourdough biscuits, sourdough pancakes are all things we can make in our kitchen without any yeast. And that's the nice thing about sourdough. Of course, sourdough is made with natural yeast, the bacteria that's in the air. So we're going to do some things all week next week with sourdough, from getting a sourdough starter started and making sourdough bread by the end of the week. And we could also use some homemade butter if you so desire. So again, I thank you all very much for joining me with Have a Science Blast with Jan, and we will see you again next week.